Hello, welcome to the video. In this lesson, we're going to be looking at section 8.4, where we're going to be finding sums of infinite geometric series. So, looking at the title, infinite means that uh, it's going to go on and on forever to infinity. And geometric means that it is going to have a common ratio, R. And series means we're trying to find the sums of uh, those sequences. So there is a way to find the sum of a geometric series, as long as there's one stipulation. The one thing is the absolute value of R, whatever it is, must be less than 1. So whether it's negative or positive common ratio, that's why I put the absolute value there. If it is larger than 1, it has no sum. It's just going to go on and on to infinity, because if our common ratio is something larger than 1, that means that each value in the sequence will increase. And since it's going to keep going on and on, it's just going to be a sum of infinity. So it has no sum. So we have to be able to identify that first. See if the common ratio is something that's less than 1. Once it's less, we find out that it's less than 1, then we can go about solving it from there. So here, they want us to consider this geometric series where it starts with 1/2 plus 1/4 plus 1/8 plus 1/16 plus 1/32. So if you notice that the numbers keep getting smaller um, as we continue on in this particular series. So what that means is if I try to find the common ratio, so if I took 1/4 and divided it by 1/2, I would get 1/2. Just double checking, 1/8 divided by 1/4 is also 1/2. So my common ratio is 1/2. All right. What they wanted you to do is consider a partial sum, but what I want you to do is go back to uh, the formula that we talked about with series for finite geometric series. So this was S of n is equal to a sub 1 over 1 minus r raised to the n power divided by 1 minus r. All right. Now, because they have 3 dots here, we know it's going to be going to infinity. But here's what I want you to do. So kind of sort of in the same idea, we're going to try to find a partial sum. So what we're going to do is we are going to choose a value for n that is relatively a big number. Okay, it's relatively a big number. So what I'm going to do is I'm going to choose a series to 100. All right, so the first 100 terms, and see if we get a relatively decent value, or at least something that we can look at. So first off, the first value of this series is 1/2, so I put 1/2 over here. This is going to be 1 minus 1/2 raised to the 100 power, and it's going to be divided by 1 minus 1/2. So if I took my calculator and I said, all right, what is 1/2 raised to the 100 power? All right, so I get some big, you know, I get this really small value here because it's like 7.89 times 10 to the negative 31 power. All right. So what you're going to do now is I'm just going to take the 1 right here. So I'm going to take 1 minus second answer, whatever that value is. I get 1. So on the top, I get 1. So this is going to be 1/2 times it by 1 divided by 1 minus 1/2, which is going to be 1/2. 1 divided by 1/2 is 2. 2 times 1/2 is 1. So they're saying that this series for the first 100 terms is going to be a value of 1. So I'm going to make the assumption that if I took the series to infinity, it is also going to equal 1. So you can use that formula to help you find um, infinite series as well, but they do have a sum formula for infinite geometric series. Again, as long as r, the absolute value of r, is less than 1. And here is what we have here. So the series will equal a sub 1, the first value in the series, divided by 1 minus the common ratio. Again, if our absolute value of r is greater than or equal to 1, it has no sum. So if we look at these examples here, first things first, I look at this rule. Does it look like a geometric sequence rule? I believe it does. This is telling me that this is my a sub 1. This is telling me that this is my common ratio. So with that being said, I'm going to use the formula. So the series is going to be equal to a sub 1, which is 3, divided by 1 minus 0.7. All right, 0.7 is less than 1. I can move forward. So 3 divided by 1 minus 0.7 is going to give me a result of 10. So 10 is my uh, series sum. Looking at B, if I were to try to find the common ratio, 3 divided by 1 is 3. Just to make sure, 9 divided by 3 is 3. If I notice my common ratio is larger than 1, this one has no sum. Looking at C, looking at the first two terms, negative 3/4 divided by 1 is negative 3/4. Just double checking, 9 over 16 divided by negative 3/4 is also negative 3/4. So found the common ratio. So to find the series of this, it's going to be a sub 1, which is 1, divided by 1 minus a negative 3/4. So essentially this is like 1 plus 3/4. So 1 divided by 1 plus 3/4 is going to be equal to, when you reduce it, it's going to be 4/7. Okay. And again, these particular ones are very similar to the other problem that we looked at. Again, you can use whatever, I would say, use whatever formulas that you'd like, and so you can have an idea of what those geometric series are. But if you have further questions, please let me know. Looking at this one here, says a pendulum that is released to swing freely travels 18 inches on the first swing, and each successful swing, the pendulum travels 80% the distance of its previous swing. They want to know the total distance the pendulum swings. So this is like a sub 1, this is a sub 2, a sub 3, a sub 4. So what they actually are telling us is that this has a common ratio of 0.8. So to figure out the total distance, what we're going to do is we're going to take the series, and it's going to be equal to a sub 1, which is 18, divided by 1 minus 0.8. 18 divided by 1 minus 0.8 gets us 90. All right, 90, and it was inches, so 90 inches. All right, last thing is talking about uh, repeated decimals and how to rewrite them as fractions. So sometimes you'll see this as like 0.24 repeating like this. And here is kind of how we go about solving this. You are kind of going to uh, show it as a geometric series. So you're going to start with 0.24 24 plus 0 point, and then you're going to go 0, 0, 24 because you have the 24 already over here. And then it's going to be plus 0.000024. And then that's going to keep going on forever. So you're just adding two zeros to each um, term in the series. So what you're going to do is you're going to treat this just like a geometric series. You're going to try to find the common ratio. So 0.0024 divided by 0.24 is 0.01. All right. I just double check here, 0.0000. So 4 zeros, 24 divided by 0.0024 is also 0.01. So we found our common ratio. So using the series formula, a sub 1 is 0.24 divided by 1 minus 0.01. All right, 1 minus 0.01 is 0.99. So this is going to be equal to 0.24 divided by 0.99. If I move the decimal place 2 units to the right, this is actually going to be 24 over 99. And 24 over 99 gets reduced to 8 over 33. And that is being able to find sums of infinite geometric series. Hope this helps. Till next time.